Welcome to our first lecture for Principles of Environmental Science. This lecture is just going to be an introduction to environmental science, why we should care about environmental science, and the major themes throughout this course. This is a lovely image that I took during my 2017 field campaign to the Arctic in Svalbard. So let's get right into it. Why does this class matter? Big question, but it's still an important one. It matters because understanding that science, when it's done correctly, is unbiased. And that means we can develop our skills, key fundamental skills in scientific literacy. So you might be familiar with the term literacy. It just means to read. What we're going to learn in this class is how to read science data and how that helps us inform our opinions about the intersection of science and society, policy decisions, and what happens in our environment. So data, data, data. It's all about the data. We can take a look at different data sets that intersect with environmental science, and we can understand that the extinction rate right now is 10 times worse than it was previously thought. We wouldn't be able to estimate that or say that without long-term data records. And so a key example of loss in a biological species is the dodo, which was driven to extinction in the 17th century. We wouldn't have an idea of how fast we lost the dodo species if we didn't have records of its population sizes. So again, all about the data. Another data set that's particularly timely has to do with sea ice cover, specifically permanent sea ice that's located in the Arctic Circle. So again, taking a look at our data and applying statistical models lets us know that we're losing about 10% of our permanent sea ice per decade. And the source for this information is the Intergovernmental Panel on Climate Change. They put out a report several years ago that documents this swift, abrupt loss of sea ice that we can plainly see just through satellite imagery. Here we have an image from September of 1984. So before I was born, we had this vast amount of sea ice, really great in extent and also pretty thick with that heavy white indicating that it's really thick. We fast forward to 2016 and we see not only is the extent of that sea ice diminished, but also we've lost a lot of that permanent thick sea ice. So we are building our toolkit for assessing sources of information, and that's what your first homework assignment is aimed at. We need to be able to separate fact, which is based on the data, from fiction. And this fiction could arise from a multitude of sources and driving forces, but typically it's spun from political ideology, monetary interests, ethical limitations, ignorance, greed, or again, just scientific illiteracy, not understanding the data and what it says and predicts. So what is environmental science? You might be asking yourself, isn't it just the same as ecology or environmental studies that you've heard about? So we'll parse this out. Ecology deals with studying the environment, both the living and non-living environment, so the biotic and abiotic components in their natural state, so unaltered, unperturbed. Environmental studies has more to do with policy, government, legislation, and the interaction between humans and the environment, social impacts, things of this nature. In this class, because it is something that I'm very passionate about, we will touch on the intersection of science and society because I think it's very, very important that those of us who are scientifically literate, we share our knowledge with others and break it down in a more accessible form. And so environmental science is a much broader interdisciplinary field. Interdisciplinary simply means that it's pulling components from different aspects of science. So you might have biologists working with stream ecologists, working with microbiologists, working with mycologists and geologists, all together for this mishmash of interdisciplinary science. So as I just said, environmental science involves many fields. Some of these you might not even be familiar with that they are fields, but it involves the fields of ecology, chemistry, physics, botany, zoology, hydrology, geology, atmospheric sciences, soil sciences, oceanography, all in an effort to understand our natural world. Environmental science does not deal with opinion or preconceived notions about things. Instead, it involves hard science. And I don't really like to use the word hard and soft when discussing scientific disciplines, but what I mean by hard is that we base our predictions and our recommendations on the data that can be measured repeatedly, statistically analyzed, and then effectively reported and communicated. It often does focus on human caused problems and how those problems impact human society, cultures, communities, but also it takes the next step in providing recommendations and practical solutions to those problems that it identifies. So let's just take one example here. Here we have a stream. Okay, so we can walk out to Maryville College Woods. There are a couple of creeks back there. I hope you have gotten a chance to be in Maryville College Woods. It's a fantastic outdoor laboratory that I love. But just looking at this image, we see that there's so many different types of environmental questions that we can ask. So for example, if you're interested in stream health, you might do a survey of the different type of invertebrate species that are living in the stream. If that's not your thing, you're more interested in the biodiversity of plants, you would do a survey of the different plants that you have here, even those that might be lichen encrusting rocks. You might be interested in the geological history of the stream. So we can take a look at the different rock types that are here and do some geological mapping to understand where those rocks came from, how they were delivered there. And finally, we can also, if we're interested in charismatic megafauna like fish, we could do a survey of the fish to identify health. And in terms of health of fish, something that goes along with that as well is chemical contaminants. So we might do an environmental chemistry analysis of the water to understand if there's any contaminants there like lead or arsenic. So in this class, I want you to consistently ask, what kind of things interest you? Of course, we're covering a lot in this course. Not all of it perhaps will be interesting to you. I hope that most of it is, but we're going to be covering a lot of different topics like biodiversity and climate change and plastics, pollution, water quality, conservation, geology, renewable energy. All of these things are studied in environmental science, and they're studied with data. It also often involves both how this affects and is affected by human activity. So to sum it up, the definition of environmental science is the systematic study of our environment and our place in it. And of course, environmental science draws on many different fields of knowledge, as I've already stated. So if we were to take this coral reef example, we can look at this problem of a depleted fishery from many different aspects. We can take a look at population biology. How many fish are needed to reproduce to re-up the population there? We can look at the ecological interactions between the reef itself and how it supports the fish. We can look at the chemistry, like levels of oxygen, nutrients, or contaminants. Again, all of these intersect to solve a single problem. Environmental science is a global subject. There are many interdependencies between global and regional systems. The very nature of how our planet works, down to the teeniest microclimates, requires an understanding of Earth's position in the greater solar system. And this just blows my mind. You may not have heard about this, but Earth is located in the Goldilocks zone in our solar system. That means in our position in the orbit around the sun, we are in just the right spot that allows liquid water to exist at the surface. If we were any closer to the sun, like Mercury or Venus, we would be too hot and all of that water would evaporate immediately. If we were farther out, by contrast, all of that ice would be locked up in a solid form. And a little side note, ice is technically a mineral because it is a naturally occurring inorganic solid. So this just lets you take the 10,000-foot view of environmental science to know that the solar system itself is an environment. So zooming back in on Earth, we recognize that our planet has an amazingly rich array of life on it. There are about 2 million known species of life on our planet, but it's estimated that there's much, much, much more, about 10 million, depending on the study. And we honestly don't know the number of species, which is part of the problem. And I'll tell you, another part of the problem is not all of us can decide upon a concise definition of what a species is. For me, I study environmental microbes, and most of those microbes you actually can't grow in a laboratory on a petri dish or in a test tube. Instead, I have to look at their genetic sequences. And the dissimilarity in those genetic sequences let me know that this might be a new microbial species. So if we were to include microbial species in this estimate, this would be several orders of magnitude larger. So let's discuss a couple of the major themes in environmental science. First, we have environmental quality. Environmental quality includes the issue of climate change, both now, in the past, and in the future. And I really love this graphic. It really drills it home that what we're seeing right now is a stark increase in the mean annual temperature in the Arctic. And what happens in the Arctic does not stay in the Arctic. In many ways, the Arctic is the canary in the coal mine, or the bellwether to signal that, hey, things are changing. We can take a look at this figure here that I just mentioned, and the shade of red represents the temperature anomaly. So how far off is the temperature now from what it historically has been? And we can see that the largest increases in mean annual temperature globally is happening in the Arctic. Extremely scary. So you all have probably heard of the polar ice cap. We're now starting to develop the polar heat cap. So this should be alarming to all of us. Another issue in environmental quality is access to clean water. It may surprise you to learn that just over 1 billion people on Earth live without clean water. It might be contaminated with microbes or chemicals or pesticides. And something that's extremely shocking, that shocked the world several decades ago, is this seminal research done by Dr. Rita Caldwell, who's at the University of Maryland. She is an environmental microbiologist. She's one of my heroes. I got to meet her last year. But she predicted that climate change is going to have a direct effect on infectious disease, especially in communities that do not have ready access to clean water. They instead rely on natural water resources. She was able to predict and then see cholera outbreaks that are tied directly to storm events and warming events. Next up is air quality. Tennessee ranks 46th in air quality in all 50 states. That's pretty alarming. And to be honest, I didn't know we were that bad. One reason for this terrible air quality in Tennessee is because the number of coal-fired power plants that we have. Here I have an image of the Paradise fossil plant that's located near Drakesboro in Kentucky. This particular plant is maintained by the Tennessee Valley Authority, or TVA. We have a headquarters right here in Knoxville. And there are just a couple of headlines to show you that it has been a persistent problem, especially in our specific area in East Tennessee. Another environmental quality issue, of course, is the loss of biodiversity. This is not only bad for the specific habitats and animals that live within that habitat, but also for the ecosystem services that peter out, and those effects ripple out in the region. And we will certainly talk more about this in later parts of the semester. Some environmental and political challenges in the realms of environmental quality. First, back to climate change. You all are probably very familiar with the anti-science rhetoric that fuels this climate denial, specifically that we have in the United States, unfortunately. But again, this class is not about opinions. I'm not here to persuade you in any way. I'm here to just show you the data that informs my perspectives and those perspectives of other climate scientists. So we can take a look at the data of carbon dioxide concentrations. In addition to carbon dioxide, we can also measure other greenhouse gases. And we can see that for the last 200 years, these concentrations have steadily increased. And this curve right here is called the Keeling curve. This Keeling curve is named after the person who set up this carbon dioxide observatory located in Mauna Loa in Hawaii. And we have here measurements spanning back from before 1960 all the way through today. And the trend is undeniable. It's this extremely steep curve increasing in carbon dioxide concentrations. And you might notice that there are some variations, some ebbs and flows, wiggles here. That's to represent the seasonal variation in carbon dioxide concentrations. But by and large, it is clear that this is an increasing trend. We can use these trends and the rate of increase in the CO2 concentration to make predictions. And so one prediction is that by the year 2100, global mean temperatures on Earth are going to increase between 2 and 6% degrees centigrade. That's extremely alarming, but it might not really register like, what does that mean? Okay, it's just a number, you know, it was pretty cold yesterday, now it's really hot, like what's the big deal? So what this does is it disrupts ecosystems and animals and plants that have adapted to those ecosystems. One example is the shrinking of the Grinnell Glacier in Montana. So scientists, through images, have been able to trace the extent of the Grinnell Glacier through time and how it has consistently receded throughout the years. So the full glacial extent in the year 1850 was here, and then 1937, 1968, 81, and 2005. And what this shows is that in the post-industrial era, we have seen physical evidence of the increasing temperatures in our environments. What else? Okay. In addition to glacial retreat, we also might increase sea levels. And this is happening now with increased storm surges and increased weather events. But focusing in on Florida, if we were to have sea level rise of 1 meter, this is the extent that we would lose in red. We increase that by 2 meters. Miami is completely gone. by 3 meters. We lose Fort Lauderdale, Orlando's gone, Daytona Beach is gone, Jacksonville, all gone, even through the panhandle here. Finally to 6 meters. So the take home is visit Florida while you can, because on our current trajectory with increasing temperatures, sea level rise, and loss of sea ice and glaciers, this is what the coastline of Florida and its panhandle might look like. Moving on to other environmental and political problems within the realm of environmental quality, we do need to talk about clean water. And so, as I mentioned before, about 1.1 billion people lack access to safe, clean drinking water. Every year, polluted water contributes to the death of 15 million people. That is just devastating. And 40% of the population live in countries where water demands now exceed the supply for water. Just think about that. There's so many people that need water and there's no access to clean water. A really good case study of this is what happened in April of 2017 when the capital city of South Africa, Cape Town, they didn't have water. They were facing a crisis. They had to basically, through collective efforts and a centralized message from the government, save themselves from this water crisis. They were saved by doing a couple of practices and mitigating behaviors like nighttime irrigation, reusing their shower water. They converted their toilets to low flush toilets to not use as many gallons of water. All of these are common sense measures. But as you can imagine, it probably took a little bit of convincing through the data to persuade people to take these actions. And so there is a video and an article for you to read on the tartan that describes these practices as well as some other ones that are probably not so sanitary if you want to take a look. But please take a look. Okay, another environmental quality problem is air quality. Okay, air quality has worsened dramatically in a lot of areas across the globe, but most notably in the countries of China and India. And that's because of industrialized companies, manufacturing and industrial practices. So here we have a map that I took this morning of the air quality going from good air quality to hazardous air quality across the globe. We see here in the United States, we do have some areas that are slightly moderate to elevated risk or unhealthy. But by and large, these deeper, darker colors are located in China and in India. At least 3 million people die each year from diseases that are triggered by air pollution. This is, not just the inhalation of noxious fumes and the like, but also particles and things that might trigger asthma. So we do have a lot more cases and instances of asthma in children, especially in those communities that are affected by these industrial practices. Worldwide, the United Nations estimates that more than 2 billion metric tons of air pollutants that don't include CO2 or windblown soil are released each year. So that's a whole lot. Moving on to another theme in environmental science is the idea of human population and well-being. So right now, the Earth contains about 7.6 billion people, and we're adding right now 83 million people each and every year. As you can imagine, this puts a lot of strain on the environment and the resources that we have to serve all of these people and to allow them to have a good well-being and be healthy. This, unfortunately, this increased population growth leads to a lot of hunger and inaccess to food, but we can combat that with information and education, as I'll get to in the coming slides. So until we get a handle on human population growth at a worldwide scale, we're not just talking about the United States or a specific country here and there, I'm talking globally. This is a global problem. Until we get a handle on human population growth, much of the other mitigating strategies that we try to enforce probably will not have any impact. And the present trends right now project a world population between 8 and 10 billion by the year 2050. Here we have a link to a video that you should watch that really illustrates and puts a finer point on this idea of population expansion and boom, especially in the last several decades. Okay, getting into the environmental and political problems of human population and well-being. Global food production has increased faster than the human population growth, which you might think is a good thing, but global hunger still remains a chronic problem. One of the reasons for the increased usage of genetically modified organisms and GMOs, they are GMOs, in the United States agricultural complex is because we need to feed a whole lot of people. Right now, at our current population, it is not sustainable to have those previous practices that we all want to adopt, in theory, but unfortunately, due to crop failures and pests, we need to rely on those new technologies of GMOs in order to feed all of us. What is truly shocking is that 40% of all the food produced in the United States is thrown away. That's ridiculous to me. And at least 60 million people face acute food shortages due to weather, politics, or even war. For example, right now in Yemen, there is a famine. There's a famine in Yemen happening right now, not because of lack of rain or poor weather, climate. It's because of war and the systemic removal of food access to these refugees that need it. But we do have signs of progress, thankfully, specifically in terms of population and education. We are increasing worldwide literacy through access to education, specifically targeting young girls and women who might otherwise just be told to raise families. Instead, we are giving them access to education to further their lives and give themselves a livelihood, build their family the way they want to build their family. And a lot of this is because of the advent of the internet, making these solutions much easier. Another aspect of this is pollution. Okay, pollution actually has decreased and population has stabilized in most industrialized countries and even some poor countries as well. We can take a look at the statistics, and since 1960, the average number of children born per woman decreased from about 5 to 2.45. So that's a good trend. Yeah, world populations should stabilize again between 8 to 10 billion by the year 2050. But it is still debated whether or not Earth can sustain that many people. And one of the concerns with the ability to sustain is the amount of pollution that we are producing, particularly in the way of plastics. Plastics is a huge concern when we're talking about pollution because it's not biodegradable. It's made of a non-renewable resource, oil, and a lot of the times we don't recycle. And what's extremely troubling right now is that China used to buy our recycling products from the United States. Okay. What's happened in recent years, I think within the last 2 years, they have stopped buying our plastics. So I'm constantly asking myself, what is happening to the plastics that I put in my recycle bin that go to the recycling center? Is it actually being recycled? We can also talk about marine resources. This does tie into human population and well-being because 1 billion people depend on seafood for their main source of animal protein. And the World Resources Institute in DC, they have a main headquarters in DC. They estimate that greater than 75% of the 441 fish stocks severely depleted or are in urgent need of better management. Okay, so right now we're not really doing a great job of managing our marine resources. And these marine resources, again, are relied upon by over 1 billion people to provide them with sustaining protein. Another thing that contributes to the well-being of the human population is, of course, energy. We rely on energy for absolutely everything. And right now, when you think of energy, you might be thinking about fossil fuels. Fossil fuels include oil, coal, and natural gas, which is methane. Together, the fossil fuels, they provide around 80% of the energy that is used in industrialized countries. But what's interesting and uplifting is that these fuels are diminishing, actually, and there may be problems associated with their acquisition and use. So this brings us into the transition of finding renewable sources of energy, like wind, solar, biomass. These are beginning to increase in popularity and demand. There is a strong consumer demand to switch to renewable sources of energy. And so companies like the Tennessee Valley Authority, they're responding in kind. Here we have a wind farm called Buffalo Mountain Wind Farm that's located in Oliver Springs, Tennessee. They also have another one that's the largest in Tennessee in Crossville. And people are switching to these alternative renewable sources of energy because they are far cheaper, easier, and faster to install than nuclear plants or even new coal plants. Coal and oil industries will not easily give up their hold on the energy market, however, so of course we always have to watch what big oil is doing and hold them accountable. Now, this is where I'm going to talk about something maybe a little controversial, but a couple of years ago, former President Trump claimed that windmill noise causes cancer. Okay, so, you might laugh, balk, and turn off the TV or change the channel and just be like, okay, he's a little, But again, in environmental science, we're not talking about opinion. We are focusing on the data. So what do the data say? Does it hold up to this claim that windmills cause cancer? We can take a look at the data and no, this is not what the data say. There was an analysis that I found that was produced in 2015 in Noise Health. This is a peer-reviewed scientific journal. And they did a quantitative assessment of the potential of obtaining a diagnosis for basically having adverse health effects due to living near a wind turbine. And they found that there's absolutely no merit to that claim. So as with anything, we do need to interrogate claims with scientific data and evidence. That's what they did. And so we find that this claim is false. So moving on from this, we need to consider a few things, ecosystem services and sustainability. These are some pretty big terms. So I'm going to try to break them down a little bit. First, we need to consider throughput. What does throughput mean? This is the amount of resources we use and dispose of. Right now in the United States, we have an extremely high throughput of disposable items that really only took off probably in the 1950s and 60s. Before then, we were always reusing things like milk bottles and containers and napkins. But now, those are all considered disposable items. So we have a high throughput of waste in the United States. Also, ecosystem services. This refers to the services or resources provided by environmental systems. And we'll talk about a little bit more of that in the next slide. A lot of the issues and problems that we discuss in this course come about through what is referred to as the tragedy of the commons. If you're not familiar with this term, it's just easily summed up as the overuse and destruction of a common resource that's driven by self-interest of many different users of that shared resource. So because it's good for farmer A to chop down his trees and till only one crop, it's also good for farmer B, C, D, E. They all do that. And in that way, they collectively deplete that shared resource that they had of that fertile land. And then finally, sustainability, the search for long-term ecological stability and human progress. That sounds so lofty, but again, that's always the goal. So to wrap up, what I mean by ecosystem services, again, resources or services provided by components of an environmental system. I love this diagram. It really sums up what we mean by ecosystem services. Each component in this system, in this community, plays a role. It might be a provisioning role, like providing food or fuel. It might be a supporting role, like soil bacteria that provide water purification services. It might be a decomposing role, right, by our fungi. It could be a carbon capture role, which in essence acts to regulate the amount of CO2 in an ecosystem. Carbon capture, of course, being practiced by our photosynthesizers, capturing that inorganic carbon, turning it into biomass, and then releasing oxygen. Again, another service providing that oxygen to all of the living community members that use oxygen to breathe.